We had different presentations today about the different layers of the cloud, different service providers, well, I would like to let's start with an all-around question. So, what do you think that what do the customers expect from the cloud service today?
Kind of in my presentation, I even tried to somehow address this question, that it's do you want to have long answer or short answer?
Short one, because all the others will also get a chance to answer to it.
Different customers have different needs, but always comes up with like some security is always the issue and the question, and then of course there is a set like minimum requirements to the cloud that it's depending on the customer. Then it's this classical like compute, storage, networking, flexibility in configuring your network, then some monitoring tools to monitor your workloads, and this is the minimum set, and all of that has to be available for like reasonable cost, because that's always something that is looked at.
Okay. Anyone else?
Okay. I would say flexibility. That's the key. Not just the services. You can scale up, scale down, but also flexibility to move from one type of cloud to another type of cloud, and that's a bit difficult. Or is it?
From the customer side, I would say that reasonable performance for reasonable price, and this performance includes like the amount of bare metal under the surface, the network bandwidth, and the speeds. I mean the response speeds from all of the services and from all of the like orchestrated stuff. So basically, if we're talking about like data centers all around the world, and interconnectivity, inside connectivity, and so on. And all of this, of course, with reasonable price.
I pretty much agree with Kalle's answer, and if I answer from an agency point of view or development agency point of view, the pricing aspect is actually quite important, whether the resources themselves or the bandwidth to actually move things around. And ease of use for like more tech-savvy startups and enterprise customers, the cloud usability is reasonable. But the rest of the world, which is actually a pretty big part of the world, the usability of the cloud is basically unbearable. So that's where a lot of work can be done.
I started as a technical person, but I'm trying to teach myself to be less technical. And I think you need to ask the question, why do we use ICT? Why do businesses use it? They use it because it helps them be better at what they're doing. And one of those big drivers, if they're a profitable company, they're trying to make a profit, a private company, they're trying to reduce cost. So I think I never look at the technology, I always look at the user. What is it they're trying to achieve? Now, if you're in the telco space, I'm an ex-telco guy, and I know that you can't change anything in a traditional telephone exchange. But once you turn it into software, then you can change things fast. And once you've configured the infrastructure in the kind of the cloudified way, once you've got a few racks in, you can just keep adding and it grows really fast. So I think it's always a case of look at each individual use case. I think there is something that's really fundamental what the cloud does, and it eats the hardware. And there's so many examples of that, especially in the open source communities. When Facebook were building out their infrastructures, you know, a large part of their infrastructure was physical cloud web servers. they couldn't build fast enough. It wasn't that they didn't have the money, they just couldn't build fast enough. So it became a software problem, and they developed Hack, and they wrote hip-hop virtual machines, and the consequence of that optimizing the physical resource was they lowered the amount of web servers they needed by 80%. And you can look at the kind of the origins of cloud. I think someone mentioned right from the days of VM. When VM started to be adopted in around about 2006 at scale by the banks, consequence of that, they did away with about 30% of their server hardware. And if you look at what's happening with containers, these kind of really lightweight instances, that's having another impact because you can run more workloads on the same physical hardware. So if you go right the way back to when we weren't virtualized and looked at the hardware there, the servers, for the same amount of physical infrastructure and the workloads you're running to where we are now, effectively this software has eaten 80% of the hardware, and that's profound.
Kalle, actually, that was a point that you made yesterday, that you are trying to fix all your hardware issues with software, actually, during the dinner, so it's very much in line with what you said.
But can you maybe comment on that? What do you see is missing from the current cloud offerings now? What's the most acutest thing in your perspective, or what do you see is there?
Yes.
Well, again, from the customer side, I would say the combined simplicity of complexity. So basically, being able to configure your services, especially if you have a complex services or complex system, and you want to really simply deploy it or to make it available, then it's really hard. Either there is simplicity approach, which Virvio or Warren is building, which provides you a really limited amount of services, and then you have AWS. Which is a bunch of APIs and tens of gigabytes of documentation, which you need to read through.
Yeah, and the certification program and training and so on. Yes. Okay. Anyone else want to comment on that? So what's missing, or what customer problem your company is solving at the moment?
Instead of missing. One thing we discussed earlier, actually, that has kind of principally gone wrong is that when we talk about infrastructure in real life, like roads and so on, then countries built them and everybody could drive, and you normally don't pay for the roads. It was a huge mistake that private companies built the networks. So in a way, the bandwidth cost disables a lot of the innovation, actually.
And I don't know, Nokia, you are in that networking.
Trying to fix that problem. Yeah.
But why did you, by the way, decide, or you're building your own data center and infrastructure in Nokia? So why build your own? Why not sell service to Amazon or Microsoft or Facebook and
Just build software.
Yeah. First of all, the core business, the mobile networks, it's pretty darn hard to run in public cloud. So it's no go. I won't say that if some part of the networks could be offloaded to the public cloud, for example, the multi-access edge computing. That's we are using AWS Lambdas for that. And we can run that on top of our hardware. So we are using some, but the key part is really difficult for that. So there is need for hardware, and as most of the network functions are nowadays available also as virtual machines, it really makes sense to provide also the infrastructure and the infrastructure software for the customers for running those network functions. So that's the main reason. And of course there is a lot of new use cases like smart cities, IoT, and all the things that comes with the 5G. The 5G is just enabler. It's not big deal, but it's a big deal what it enables. So that's huge thing that we are really looking forward. Actually, we will fix your latency issues really soon. Yeah, Google 5G network slicing. That's the cure for that.
Did we only have a pricing issue?
Sorry?
Did we only have the pricing, traffic pricing?
Oh, yeah.
Well, Telia will. It's a discussion with the local operator.
Yeah, I guess in Finland, Telia just, although the 5G license tender was just held, Telia at least was proud. I don't know how far it is in other countries to get the last mile really fast. So, yeah. But then one thing we discussed was this huge energy need of data centers. So I don't know, John, do you see that OCP is a solution to that, or how we as an industry overall solve this? I don't know, using 20 or 25% of the overall electricity production in the world.
I don't think it's a problem, and the reason I don't is because when you use software to eat the hardware, look at a traditional enterprise data center, the average utilization of the server might be 6 to 12%. There's research coming out of the European Union showing that in European government data centers, servers are idle for nearly 80% of the time. It's crazy. So if you can share that hardware resource much more efficiently and start putting the CPU utilization up, instead of running at 5%, 6%, start pushing it, get 10 times more workload on it, then what that means is you can eliminate 80% of the hardware in the enterprise space. Most enterprises run very inefficiently. So if you looked at all the servers currently in the world, only about 20 or 30% of them are in the cloud space. The rest of them are in these tiny little enterprise data centers. Now, if the enterprise data centers, which are currently being consumed by the hyperscalers, because the hyperscalers are just doing things smarter, if you just used the kind of the software and the innovations in the hyperscale and took them into the enterprise space, you could eliminate today, for the same workload, 80% of all the world's servers, in theory. Now, what would be the impact of that? It's a huge reduction, and I think this problem will go away once people start to use these modern practices of using the software to eat the hardware. That's my
Maybe quantum computing is the answer.
Oh, that's further on.
Or maybe we can also think of layer higher, so that what people overall are using IT for. So watching useless YouTube videos would probably eliminate like, I don't know, 60 or 70% of the network traffic overall and save a lot of electricity in that.
Well, you say that, and I see the software is not just eating the server hardware, it's eating everything, because what the software does, it allows you to share hardware resource efficiently. I don't know whether you've seen the latest studies about the manufacture of motor cars. There's a company in France called BlaBlaCar, which is a car sharing business. And it was started by a software engineer, a French guy who was coming home from America, and he couldn't get a lift during this Christmas period, and all the taxis were shut down, and yet there were all these cars on the road with one person in. And he's sitting there, painful, and he's saying, I'm sure I can write a software app that would allow me to make this journey. And he did a quick study, and he looked at the French private motor car ownership. And the average spend on a private car in France at the time when he did it a few years ago, and I heard this on a BBC interview, he said people spend about 5,000 euros a year. So that's depreciation, petrol, maintenance costs. And then he said, for 94% of the time, the car's not moving. And then he said, there's a certain percentage where they're in the traffic jam, then you're spending another percentage trying to find somewhere to park. The actual time you spend travelling from A to B, which is the function for the car, is something like about 2%. And then he went on to say, which really hit me hard, he said, and then 3 out of every 4 journeys, there's only one person in the car. So if you measured the effectiveness of the asset of the seat that moves the person. We're talking about running these physical infrastructures running at less than 1% optimized. So he knew that he was onto something with software. Now what's interesting, once you start to get into autonomous vehicles using software to optimize them, there are predictions, and you can see these predictions, this research coming out, that by around about 2040, car production globally will fall by 80%. Now if I'm only using the asset at kind of 1%, you can see I'm not being bold by that statement. I'm not saying 99% because I'm building in 20% capacity in the hardware. This is how profound it is, and you'll see it absolutely everywhere. And I think this is one of the most profound things we're going through. This is the next industrial revolution, and it's because software is eating the hardware.
So one topic we talked about was the edge data centers. So do you see, for example, how is the process going to go in the future? Will we have Amazon and Microsoft mini data centers all around in each city that has a population of over, I don't know, 100,000 or 50,000? Or will there be local players, or is this needed overall? Will there be high-speed connections, or what? Do you have an idea how the process in that sense will develop in the world?
Needed, absolutely. It's difficult to predict if it's, but those big players will do. But certainly there is like space for local and.
Yeah, so the big players will be there, that's for sure. They want to extend the cloud closer to the end users, that's for sure. Another thing, what we trust is that telcos will deploy the edge, and it's not. Well, we designed the Open Edge box. It's actually the same size as our base station, so it fits the existing cabinets of the base station, the mobile network base stations. So that's obvious choice of the point of presence there for the compute. You have connectivity both the radio for those small Death Star robots, and you have fiber. Most of the places you have also the fiber there. So that's the telcos has the point of presence for edge for sure. And then I'm quite sure that local players that can be more flexible than Amazons and Googles of the world, they will also deploy the edge clouds or edge computing for cities.
It's interesting. There's all this hype at the moment about edge computers, and there's all these people getting into these containerized solutions and thinking there's going to be a huge business. But when you look at the way that telephone exchanges are laid out in cities, the actual radial distance from any point, normally in a city, is about 4 kilometers. It's not very big. Now what's interesting, 4 kilometers, and if I've got all the infrastructure, all the fiber is there, if I convert the telephone exchange into a data center and virtualize everything, why do I need to run anything else out? The telco then becomes a cloud service provider. Now there's negotiations between Amazon and Telefonica. Telefonica are converting about 800 telephone exchanges in Spain, and it's got something called CALL. If you want to know more about it, these guys are all involved with it. CALL stands for Central Office Re-architected as a Data Center. And so Amazon, in negotiation to buy services, cloud services, instances of compute, network and storage in the telephone exchange, no more than 4 kilometers away from nearly everything. And what's 4 kilometers of fiber in terms of latency? It's nothing. It's absolutely nothing. So if the hyperscaler has a problem with latency, he just brings up an instance in a telephone exchange 4 kilometers away. Now the problem is that telcos, they're so slow, and this is a real big problem. I get it everywhere I go when some telcos are running ahead fast, really fast. SK Telecom, they're moving really fast. Telia is an innovator. You just watch what they do as they virtualize their exchanges. But those that don't, they're going to be eaten alive. Now, what's happening as well, they're also, the telcos, if they don't move fast, they're going to lose this facility to be selling services in their telephone exchanges, cloud services, because there was an announcement just last month from eBay. They want lower latency into the city, and they're going to start building their own edge data centers. Now, if the hyperscalers do that, then that's the end of the telcos. So the telcos have to move fast, and if they don't, the hyperscalers will continue to cannibalize their revenues and destroy them. At the moment in the world, there's probably about 280 telcos. What's it going to be like in about 4 years' time? If they don't move fast, they're going to be eaten alive.
Any comments more on edge?
Basically, I think that the edge currently is like somewhat addressed in the sense that AWS, for example, with its CloudFront is having the like POPs and everything, but this is like little drop in the ocean. But the edge is also something that is a little bit, I think, I don't know, maybe overhyped because it's like a per industry need. For example, telcos need the edge in a sense of having the like best latency from the phone to the POP, but the backbone is still in like 2 or 3 cities in the country. For example, in Estonia there is only like 1 POP, which means that you don't have a sense of building like a data center in or the like edge location in Jõhvi, Tallinn, Tartu, Pärnu, and so on, because all of the traffic comes from Tallinn, right? And also the distances are small, and same goes for the like other countries. Although the density is a little bit higher, maybe, or the countries are bigger, but still you always need to consider the POPs for the like end consumer. And for example, in our case, when we're using mainly mobile traffic, this means that in US we have like total of, I don't know, 5 to 10 cities in which to have like edge POP, because the mobile connection terminates in there, and this is like sufficient, and this is like more or less covered. So it's a per industry need, and the like more time critical you are, or more real time you are, again coming back to the telcos who are filthy rich and so on, then they can like afford this thing and they can drive this thing, but this is not for like commodity or everyday use.
One thing maybe that the appliance concept that Kaur showed before, so basically it's a more a personal use case of the edge device, so it's actually the home or office. Just to short calculations, comparing to, for example, you probably don't put any production workload there or so on, but testing stuff and staging and so on. Comparing the cloud prices for our agency side, we could make the monthly cost per compute about 5 times smaller using those kinds of applications. Getting something 5 times cheaper is actually quite important. So.
Okay, next question, maybe all of you can answer this, but what would you say is, where is it happening the most, or what would be the technologies, countries or companies that you would really follow now? What's the next innovation or big thing in the next 1 or 2 years? Besides Warren, I know, but...
Everything will go multi-cloud, that's for sure. So there will be basically a cloud of clouds or another layer. I don't know how fast it will happen and who will play the biggest role, but overall it will happen. So it will become more or less like electricity.
Distributed computing, in the sense that for example, if you're taking like self-driving cars or self-driving robots, then the amount of computation that is needed is like pretty heavy. It has lots of peaks, and this is like something that is really hard to like achieve within one data center or one availability zone or one server, and I mean, evenly distributing the like basically distributing the CPUs around the globe in different places.
I would love to say 3D printing, but it's a bit far. And well, all the use cases related to automation, and of course it's backed up with edge computing and general cloud computing principles, but anything related to automation, autonomous vehicles, drones, smart cities, smart grid, power grids, everything related to automation, that's the thing, eliminating the human factor from the equation.
Maybe extend it a bit, and all kinds of robotics actually, so that everything that eliminates the need for physical work and makes life easier for people. This is also the area that is developing very fast, especially with help of all kinds of software now. It's not much about hardware; it's software. So.
Well, in my space, I just think of, I mentioned that Gartner is saying that traditional enterprise data centers are closing at a rate of 10% per annum. Now, if I was an employee in an enterprise data center, and you could see what the hyperscalers are doing and how efficient they're doing things, wouldn't you think that if we adopt that, then we won't be closed down because we're running too expensively? I think people will twig soon what's happening. I'm talking to some very big enterprises, governments are moving into this space, and they're not, because what happens is when you're a very large enterprise, and it was interesting how much you push into the Amazon cloud, what we find is when they get very, very, very big, you then think, oh, this is very, very expensive, I need my own infrastructure. So I think these numbers are starting to come out when you're really big, like a big global banking system. They push so much, and then they start looking at the numbers and they go, And then, now they know that they've got the ability to change the hardware infrastructure to build data centers at half the price. You can almost build an OCP optimized data center with about 1,000 servers in, right? For about the same price that you built a traditional tier 3. And all you got in the traditional tier 3, you just got the building, you got all the stuff that we don't really need anymore, and you can build a whole data center with the IT and the storage and the networking as well. So I think that's going to be a big thing, but the problem is there's no supply channel to do it. So there's this huge demand that's starting to bubble up. And some of the big banks, I work with the big banks because they're really keen on this in Europe, because they've seen what the American banks have done. And I did a workshop with a very big global bank based in London. After the first workshop, they went away with some of the energy efficiency figures purely just on, these commoditized servers. And when they came back to the next meeting, they said, if we just kind of changed all our old servers out for this, we'd save £20 million a year just on electricity. That's not doing any more virtualization, that's just changing the hardware. So I think there's going to be a kind of a reinvention again in the enterprise space, and it's something that always happens. You start with concentrated mainframe centralized distribution, we went distributed, we had servers under people's tables, we then consolidated into server rooms, we came back, and we're right now back into this large consolidated data center, and it's like you said, we're going to go back out again. There's a kind of a pendulum that's going on about centralized, distributed, and I think it will just always go on. It's almost like a phase of life. That's what's going to happen. So, because at the moment you've got these dominant monopolies, if you like, with the centralized hyperscalers, but people can now copy those ideas. They're all open ideas. You just take them, and move them.
Okay, so do we have questions from the audience to the panel? Or any comments?
John, on your talk, you mentioned that the OCP lacks the software layer, or there's a lot of potential there. So I'm a software engineer, so for me to be interested in the OCP, I want to see exactly what is this gap where is this potential? Because we already have the Docker containers and the virtualization and all of that. So what was your message? Maybe you can explicate on that.
Well, when you buy a piece of open source hardware, there's nothing on it. You unbundled all the software. You just buy a lump of tin. It's got processors in it and memory and that kind of thing. So you need to put, initial operating system on. But the real magic is, I think, the orchestration layer. And if you can take bits of commoditized hardware, open source hardware, and start to do the orchestration layer, the OpenStack kind of orchestration layer, then there's great potential if you're into software. And if you're a Python engineer, then there's some great stuff, because that's what it's all about. So you can really do something special. And just by running OpenStack, there was a wonderful conference in Australia, OpenStack conference. And just to give you an idea of the scale of OpenStack, the last conference I think they did last year or earlier this year in Texas, had 7,000 people at it. Just an OpenStack conference. And there is this kind of intimacy. If I'm looking for anybody who's looking to commoditize all their hardware and go open, I look for people who are playing with OpenStack. And it just seems to happen. They run OpenStack infrastructures and then they say, well, why do I need all this expensive stuff at the bottom? It's giving me a problem, it's expensive, I don't need the same kind of hardware redundancy that I used to have, because I'm doing it in this orchestration layer. So I think if you're a software person, I think get into the orchestration layer. And if you're an OpenStack guy in London, you can earn a fortune. You can earn a fortune.
That you would then pay for the rent of your apartment.
You won't be able to live there. So, yeah.
Any other questions? Any questions from the panel to the audience? Because if not, then...
Can I ask you a question?
Yeah? Go ahead.
I'm very keen to kind of bubble stuff up here, because one thing we're lacking in this, the hardware is becoming commoditized. What's needed is clever kind of software integration. And what's special up here, you have that talent pool. And I'm looking for people, if they are interested, you're interested in getting involved, you have software skills up here that you could partner with companies who are if you look like the old hardware primitives, who used to buy a piece of hardware and it had all the OS on it, and they used to move it in like a lump of tin. Whereas you move into open source hardware, you need clever software people. So I would like to see the potential of you guys partnering. You're never going to become big manufacturers, but the opportunities for you people who are good at software, and this is not just here, it's almost like the whole of Nordex, I think is a huge opportunity. And I would like to develop more of these seminars and more educational aspects of it and bring relationships into the country to stimulate this, because at the moment, part of the problem on the adoption is we don't have the people with the software skills to do the integration.
What's the comment? Would you like that to happen? Would you like to see that more, that we do more of these focused seminars? Yeah? Bring external companies that need your type of skills. Yeah?
Mm-hmm.
That would be something, yeah? Okay.
This is Estonian resounding yes.
That's yes, yeah. Silence is a yes in Estonia.
It's really funny, because when you get in a cab in Estonia, they never talk to you. But I've worked in Estonia before, and I remember the first time I ran a training course on data center design awareness, and I did it for this large American company, and had 20 people in this class for, 3 days. And he said, they're just going to sit there and look at you. They're not going to do anything. Not going to do anything. And I thought, well, there's my challenge. So my challenge was to find somebody in that audience, yeah, who was going to bite on something. So I kind of almost teased them for the morning. And then this guy popped up, a little bit like you, yeah, the provocateur, and it all started to happen. So I don't think it's typical. I just think you're slower to start, but it's the climate. You're cold-blooded, you're like reptiles. Once you're warm, you're great. That's good stuff.
Okay, but then thank you. It has been a nice conference. We thank the sponsors and the magicians and the presenters from my side and from Warren and Bill and Ostrek Latham. and hope to see you all on the next events. And there's coffee and cake provided at the coffee room after this. Okay, so thank you all.
ja Märt, sulle ka aitäh!